Let's talk a little bit about the importance of the throttle plate itself. It's one of those things you tend not to really think about it. It's just there, it's blocking air and letting air through. There's a lot more to it than that. If you look at the side of the carburetor body, you'll see that the shaft itself is not in a right angle to airflow. It's angled a little bit. If we take the plate out, we'll see that it's angled as well. And the plate is angled so that it is going to create a perfectly tight seal, not just at the edge, but along the whole surface of it. Now, the reason this is so important is because at really small throttle openings, the plate determines not just the amount of air that comes across that first bypass hole, but the characteristic of the airstream itself. And if we want every single carburetor body to have exactly the same characteristic at the smallest throttle openings, which is where they're the most sensitive, we want to make sure that these edges are just like a knife. But if there's a little bit of burring or irregularity on the surface of the plate, we can deal with that in such a way that we don't upset. If we were to get on this with a file, for example, and file away at that edge, let's say you feel a burr there and you break that edge off by filing on it, what's going to happen is at an extremely small throttle opening, you're going to get a completely different air-fuel mixture profile from this plate as opposed to a neighboring carburetor where we didn't file that edge. This carburetor body is not going to idle, and it's not going to come off idle the same as its neighbors. So by fiddling around, by damaging these edges, or by not paying attention to their importance, this is another place where we can inadvertently introduce a lot of variables that are going to be impossible for us to figure out later. The places where throttle shafts tend to deform a little bit is right at the edges because they're constantly rubbing. At idle, the plate isn't fully closed, so it never actually is going to come into full contact with the upper and lower parts of the bore. So we don't really have to worry so much about hammering out here, but they do get a little bit deformed just from years of turning, and they can also deform a little bit over time just because of the nature of the shaft and the way that the screws go through to hold it. So the way we deal with this is we set the throttle plate perfectly flat. I use a stone. I'm not going to use the stone on the face of it. I'm only using the stone because it has a perfectly hard and perfectly flat surface on it. I'm going to wrap some 600 grit wet or dry paper on it, and I'm going to hold it down firmly, and I'm going to use it only perfectly flat. I'm never going to allow my sanding block to come off, because that again can break onto that edge and destroy this throttle plate. So I'm going to go around it kind of in a circular motion. You don't need to press down real hard. And I always want to keep the pressure of my finger on the center of it so that it never gets a chance to skip like this. Once you got a feel for this, it's really not difficult to do, but it's a real important part of the process, because this can determine how easily this throttle plate will slide back into the shaft itself. And if it's got a little burr on it and it wants to hang, it can make it nearly impossible for us to do any super fine tuning when it comes to making sure that it's closing all the way. So we do a surface dressing on the edge of it. It removes, excuse me, not on the edge, on the face of it. I'm not used to being on camera, so I can kind of get tongue-tied sometimes. Plus, if I've had a quad latte. But now that we've got it fully dressed, all the burrs are gone, and it's going to slip when it's all put together. When we need for it to be working perfectly, it's going to slide through there with the greatest of ease. And we're not going to have wrecked this all important edges.